Hi everybody, Morgan here. We are starting off our unit on electrochemistry, which is one of the required units in the AP outline, and in addition to that, it's a unit that I just would not feel comfortable with you leaving the class without already knowing this material. It's pretty pivotal material throughout the year. And it is going to have a lot of application in other classes as you go on. Now, especially if you get involved in biology, looking at things like neurology and vision, it becomes really important. So, we're on page 1 of the new outline, and we have some review stuff. And this is going to date back actually to the first couple weeks of school, where we talked about oxidation and reduction reactions. So I just kind of want to wake you up a little bit. Now, first thing I'm going to do is actually tell you to pause your video and try to do this stuff. And we'll go through section by section. So in here, we have a bunch of compounds, and I'd like you to assign oxidation numbers to all of the elements in the compounds. Okay, I'll hold on while you do that. You can pause. All right, welcome back. Okay, hope you were pretty successful here. So let's start with KMNO4. We know that the oxygens are -2, and I write it 4 times because there's 4 oxygens. And potassium is a +1 because it's in group number 1. The oxygen -2 is one of those rules that we just have. So I have 8 negatives and 1 positive. That means the manganese must be +7. Okay? Now, here, NiCl2. I know the chlorides are -1 each one, typical ionic charge for a chloride. So the nickel, which can have various charges, this time will be a +2 because of the 2 -1s. Here in FeO, that oxygen's a -2, that's our oxygen rule. So this iron must be a +2. Now here a little bit different. I have 3 oxygens, -2, -2, -2, which means I must have a total of +6. It's divided over 2 irons, so each iron is a +3. And this is probably a good time to make note of something. Remember, you're assigning an oxidation number to a specific atom, not to a group of atoms, not to a molecule, but to a specific atom in the formula. And that becomes a big deal here with Fe3O4. If you try to do it normally, you end up getting a fractional charge for the iron, which is not possible because we're talking about electrons moving here. So, turns out that Fe3O4 is kind of a silly way that we abbreviate the compound FeO.Fe2O3, which is a mineral, okay? Now, we know each of the oxygens are -2s, which means this iron's a +2, and these irons are +3. So while not common, it is possible that multiple of the same atom could have different oxidation states, but it's pretty rare. Okay, so here, sodium oxalate. I know the sodiums are +1, +1, and the oxygens are -2, -2, -2, -2. So that's a -8. Okay? And here I have a +2. I need 6 more positives spread out over 2 carbons, so they must each be +3s. Okay? H2O2, peroxide. The oxygens are -1, the hydrogens are +1. Peroxide rule. Copper 2 oxide, the oxygens are -2, and I'm showing this to you just because it's rare, but it does exist. Copper can exist in a +1. Beryllium hydride, again, it's a hydride, so the hydrogens are -1s. That beryllium is a +2. You can always recognize a hydride because it starts with the metal. They're called metallic hydrides sometimes. Okay, so in our next section, we're going to be identifying the oxidizing agent, the reducing agent, the substance being oxidized, and the substance being reduced in this following reaction. Why don't you go for that and pause and come back when you're done. Okay, welcome back. Hope you were successful. I see that right away. A magnesium that's all alone means it has an oxidation state of 0, and it's going to a +2. That means magnesium is being oxidized, which means the SiCl4 must be reduced. That's actually easy to see also because it's going from a +4 to a 0. So if this is oxidized, it's the reducing agent, and if this is reduced, it's the oxidizing agent. Okay? There we go there. Okay, so now we're going to balance one reaction in acid and one reaction in base. So I'm hoping that you can remember those steps that we do. The first of which is to break it into the half reaction. As2O3 gives you H3ASO4, and NO3 minus gives us NO. Okay? Balance everything except the hydrogens and the oxygen, so I have to put a 2 there. That's going to affect a lot of things, actually. Okay? Next thing is to do oxygens. So 2 times 4 is 8. I've already got 3, so I'm going to add 5 waters. 3, 1, I'm going to add 2 waters. Okay, hydrogens, just H pluses because it's an acidic reaction. Okay, 2 times 3 is 6. 2 times 5 is 10, so I'm going to need 4 more H pluses over here. 2 times 2 is 4 with none, so I'm going to need 4 H pluses over there. That's kind of convenient for the time being, at least. Okay. Now, to do charge, I have to add electrons. And the only thing that's charged in this first one is this. So I'm going to add 4 electrons here. 4 H pluses, so 4 electrons. Here I'm going to need to add 3 electrons because I have a 4 plus and a -1. So I'm going to have to multiply this top equation by 3 and this bottom one by 4. So I'm going to switch colors here to hopefully make it a little bit easier. 3 times 5 is 15 H2Os plus 3 As2O3 gives us 2 times 3 is 6 H3ASO4 plus 3 times 4 is 12 H plus, and 3 times 4 is 12 electrons. Here I have 12 electrons, yay. 4 times 4 is 16 H plus. 4 times 1 is 4 nitrates. 4 NOs. 2 times 4 is 8 H2Os. Sorry, that's bunched up a little close together. So 12 electrons will cancel 12 electrons. 8 waters will turn that 15 into a 7, okay? 16H plus and 12H plus, so the 12 will be gone. That'll leave me with a 4. So what does that leave me with? 7 H2Os plus 3 As2O3 plus 4H plus and 4 NO3 minus. And I think that's everything on this side, okay? So on the other side, I have 6 H3ASO4 and 4 NOs, and I think that's actually it. That's everything I have there, okay? So the right side's pretty compact. Okay, so that's one in acid. Go out and try the one in base. Tune back in. Welcome back. Hope you did okay on this. All right. The ones in base tend to take a little bit longer. Cn minus gives us CnO minus, same as in acid. There's only one step that'll be different. MnO4 minus gives me MnO2. Okay. 1 carbon, 1 carbon, 1 nitrogen, 1 nitrogen, 1 manganese, 1 manganese. So that step's pretty straightforward. Okay, so now we're going to do the oxygens. I have an oxygen here, so I'm going to add a water there. I have 4 oxygens and 2 on the other side, so I'm going to add 2 waters. Okay. Now, to balance the hydrogen, it's different. I'm going to add a combination of OH minus, H2O, or H2O, OH minus, to differing sides, depending upon which one needs the hydrogen. Okay, this needs 2 hydrogens, so I'm going to add 2 waters, and on the other side, 2 hydroxides. 2 times 2 is 4 hydrogens, so I'm going to add 4 waters and 4 hydroxides. We're adding a water for every hydrogen that's needed, and then a hydroxide to get rid of the O and the other H. So we just have a net addition of 1 hydrogen. Okay, so now charges. 2 minus and 1 minus is 3 minus. I already have 1 minus, so I'm going to add 2 electrons here. 4 minus, here I already got 1, so I'm going to add 3 electrons over here. Bummer, I'm going to have to multiply both equations by something. This by 3 and that by 2. All right, switching colors to make things clearer. 2 times 3 is 6 hydroxide plus 3 waters plus 3 cyanide to give me 3 CNO minus. 2 times 3 is 6 waters and 6 electrons. 6 electrons plus 2 times 4 is 8 waters plus 2 MnO2 minus to give me 2 MnO2 plus 2 times 2 is 4 waters and 8 hydroxides. Okay, 6 electrons and 6 electrons. Now those 6 hydroxides, I'll turn that 8 into a 2. 6 and 4 waters is 10, 3 and 8 is 11, so all of those are gone, leaving me with just 1 water. So I now have 3 Cn minus plus an H2O and 2 MnO4 minus to give me 3 CNO plus 2 MnO2 plus 2 OH minus. Okay, so if this is not fresh in your mind, you can go back and practice again from the beginning of the year, but we will definitely need to know oxidation numbers, who's oxidized, who's reduced, and we are going to be doing some balancing. Okay, so that's it for page 1. That's the first lesson. And tune back in for our next lesson, which will cover electrochemical cells. This is Morgan, hoping you have a good day.